Okay, so the question would arise if we're looking for odd powers of sine and cosine in order to do the integral, then what happens when there are no odd powers of sine or cosine? Well, here's an integral that has that as the case. Sine is to the second power and so is cosine. So we cannot find that odd power of sine or cosine that we need to isolate the du. So what we're going to do is we're going to resort to the half-angle formulas. So I'm going to modify this integral using those half-angle formulas. The sine squared of x is equal to 1 minus the cosine of 2x over 2. The cosine squared of x is equal to 1 plus the cosine of 2x over 2 dx. Okay, so once you've done that, notice now you have sine or cosines to the first power. It's still a product though, so we still have to do something to clear it up because we don't necessarily have the wherewithal to do integrals involving products, and we don't want to do it by parts. So what we're going to do is we're going to clean it up a little bit. 2 times 2, I can take out a factor of 1/4. 2 times 2. Then when I multiply the numerators, well, the numerators are actually conjugates. So when I multiply them, I get a difference of the two squares. 1 minus the cosine squared of 2x dx. So this is the integral I'm looking at. All right, let's go ahead and do it term by term. The first one is going to be 1/4 times the integral of 1 dx. The second one is going to be 1/4 times the integral of the cosine squared of 2x dx. So I have these two integrals to do now. This one is still tricky because this one still involves an even power of cosine. An even power of cosine. So since that one has an even power of cosine, I'm going to modify it by using the half-angle formula again. So this is going to be 1/4 times the integral of dx minus 1/4 times the integral, and now I'm going to use the half-angle formula again. Since it's cosine squared of 2x, well, this is 2x, then I'm going to get 1 plus the cosine of 4x over 2, since this is already 2x. Since it's already 2x, I'm going to get 1 plus the cosine of 4x over 2 dx. And there I have two integrals now. The first integral is going to be relatively easy to do. That 1/4 integral of dx. Then minus, I'm going to split this up into two terms, 1/2 and the cosine of 4x over 2. So it's going to be negative 1/4 times the integral of 1/2 dx, and then minus 1/4 times the integral of the cosine of 4x dx. Okay, let's see. Let me clean this up a little bit. This is 1/4 the integral of dx. This is negative 1/8 the integral of dx. So I have 1/4 of that integral minus 1/8 of that integral. Then minus 1/4 of the integral of the cosine of 4x dx. Well, these two are actually like terms that can be combined. I have a 1/4 of something minus 1/8 of something. If I combine those, I get 1/8 of the integral of dx. Because this is 2/8 minus 1/8 of the integral of dx. Those are like terms, Then minus 1/4 of the integral of the cosine of 4x dx. This integral is easy, that's just 1/8 x. This integral, I'm going to do a U-substitution. I'm going to let u equal 4x. If u is equal to 4x, then du is equal to 4 dx. du is equal to 4 dx. So I can rewrite this integral. Let me see, it'll be 1/8 of the integral of dx minus 1/4 of, well, now if I want to do this integral, let me see, I have integral of the cosine of 4x, but in order for me to have du, it would have to be 4 dx. I don't have 4 dx, I only have dx. So I'm going to put a 4 in. I'm going to put a 4 in so I can have du. 4 dx is du, but if I put that 4 in, I also have to divide by 4. So I put a 1/4. I put a 1/4 on the outside. All right. So let's see what we have here now. So in this case, this just becomes 1/8 x. In that case, that's just 1/8 x. And let's see. Oh, I forgot the factor of 2 here. There was a factor of 2 in the denominator of the cosine. Forgot the factor of 2 here. So it was 1/2 and then the cosine of 4x over 2. So 1/2 and the cosine of 4x over 2. So there should be a factor of 2 here, which means this should not be a 1/4, it should actually be a 1/8. That should actually be a 1/8. So everything works out. I just forgot that there was that factor of 1/2 in the cosine of 4x also. There should be a 2 in the denominator here, because I'm splitting the denominators. I'm splitting the 2 amongst the 2 terms of the numerator. So it should have been this. So now I get down to here. Okay, now I have this. The 1/8 integral dx is just 1/8 x. And then this is minus 1/4. 8 times 4 is 32. And then that integral is the integral of the cosine of u, and there's du. When you integrate the cosine of u du, you always get the sine of u, which is 4x plus c. So here is the final answer for this integral.